Hey everybody, this is Larry. This is me going over Strange Printer 664. Hit the like button, hit the subscribe button, join my Discord, let me know what you think about this one. So this is a quick intro. I already have it solved. You may watch this video and notice it's very long. It's over 2 hours long. And the reason is actually very subtle. So I'm just gonna this is a little bit of a spoiler in any case, but yeah, I think so. Just to kind of give you a setup for this video, the next 10 minutes or so, I talk about dynamic programming, how to set it up, and then I actually solve this. You know, if you want to go over the live portion, I actually solve this over half an hour or so. So you can watch the live portion and kind of see how I progress toward it. And then I'm going to do another cut in explaining what went wrong on that thing, because I end up spending another hour and a half analyzing the problem from different ways, just trying to learn myself, right? And there's a very subtle thing that happens with this problem that I will go over when that second part comes in. It should be about like half an hour or on the live portion, so about like 40 minutes plus whatever it is now, 40 few minutes. Basically, if you want to skip ahead and you see the first time limit exceeded, that about that time, I'll edit it in so that I actually explain the solution. So definitely stay tuned for that. Anyway, it's a weird setup because the video is really long. It's not as bad as it is long, but there's a very subtle thing that makes this problem kind of tricky. And I go over it a lot. So yeah, anyway, that part I'll talk about it next, so stay tuned for that. And here's the real the live portion. Here's me recording it live so you can watch it now. Hey everybody, this is Larry. This is day 21st. I don't know, I said it weird. Hit the like button, hit the subscribe button, join my Discord, let me know what you think about this one. Yeah, just a quick Larry marathon update. I think it's in like 65 days or something. I don't know. Well, actually, let me check it real quick. Because I should know this. I mean, maybe not. It doesn't matter that much, the actual number of days. But I'm actually doing the Marine Corps Marathon in DC. So, 24 days prior is not that one. So, I don't know. If I have fans or whatever, or just friends, I don't know, who is in the DC area and you want to see me do it, 68 days. If you want to see me do the marathon, I guess, I don't know, then you could check that out. Maybe if people are actually interested, I'll post a link or something. But yeah, today I did a speed day, only 8 miles or so. So I don't know, a little bit tired, but not too tired to do this problem. So let's get to it. But yeah, alright, today's problem is 664 Strange Printer. I vaguely remember this one being really hard, so we'll see if I actually get it today. But, I don't remember the details, but I remember people keep on asking me about it, and I always have trouble with it. I think one thing that I would say, and this is why we practice, right, is that when I did this problem, I definitely have done it, so I don't think it's too much of a spoiler. Yeah, when I did this problem 5 years ago, I definitely struggled a lot. I guess 5 years is a long time, so I don't know what to say about that one. But when you talk about practice, I feel like I have gotten better at dynamic programming in general. Even though even back then, 5 years ago, I was probably like very good at it. But now I've gotten better just because, I don't know, Leetcode keeps on giving us random dynamic programming problems. But practice and all these things. Anyway, I don't remember this problem, or I don't remember the detail because I remember there's like, the reason why I say I remember it but I don't actually remember it is because I know that there's like 5 or 6 dynamic program problems that I remember struggling with in Leetcode, but I don't know which one's which off my head. I don't remember the problem. It's just, I just remember the feeling of struggle. So yeah, all right, let's take a look. 664 Strange Printer. There's a strange printer with the following 2 special properties. The printer can only print a sequence of the same character each time. At each turn, the printer can print new characters starting from and ending at any place and covering the original existing characters. Given a string S, return the minimum number of turns the printer needed to print it. Okay, I think one thing, the two things I want to say, right? I think that we often say, even though it's not always true, that dynamic programming is just try every possibility, but add memorization. I mean, it's often true only because the problems that people encounter at the skill level, the Leetcode level, that's true. Because if it gets harder than that, it's too hard for a lot of people, and also maybe not good enough for an interview, right? Like it's too hard for an interview, so that's why. But in code forces, you'll definitely see more difficult dynamic program problems that are not quite just brute force, but add a memorize, right? I mean, there's some stuff about states, but even a lot of those state stuff are brute force, right? And stepping back a second and just talking about dynamic programming is about making is about finding out how to make an optimal decision that generalizes in a from its subproblems to super problems in that way, right? And what I mean by that, what I just said, like the two things I just said probably sound very alike, but the difference and what I mean by that is that, well, one is that you don't always brute force. I mean, one way to do it may be just to brute force all the possibility, like all the branching possibilities, do the math because the states are they're not in that many states, and then kind of take the best out of those states, right, in a transition kind of way. But it's not always true, right? Or it's not always the best way because that may be just too expensive, right? You have too many states, so sometimes the idea is being able to create these states, but also make greedy decisions along the way. So in a way, I mean, most dynamic programming problems will require most dynamic programming problems do actually require a greedy logo thing to kind of like be like, okay, for all these loops, which one is the most whatever, right? Like the max or the min, and then just take it from there. So that's kind of like a local greedy proposition that's very obvious in a way, at least locally, right? Like if you want to generalize that optimization or that greedy decision, it might not always generalize, but for a given state, and you have all these transitions and you take the max, that itself is a greedy idea embedded in dynamic programming, right? However, so that's like a easy version of easy version of the greedy in dynamic programming, but it's not always true, right? The thing is that, or it's not always true that it is easy. Sometimes you have to make tough, greedy decisions that are a little bit tricky. I don't know if that applies here, but that's the distinction that I want to make, right? And sometimes that greedy part will require proof, or at least require proof if you want to be confident. I mean, I guess you could always YOLO, but so that's part one of what I want to say. Part two of what I want to say about difficult dynamic program problems is that I talk about, and I bring this up a lot, even though it doesn't always apply, is this idea of a symmetric dynamic programming problem, right? And what I mean by that is that it lets us be lazy. Or not lazy. Lazy is not the right word. It let us be careless. It let us get sloppy, right? And what I mean by that is that, let's say Fibonacci, right? The most basic dynamic program problem. It allows you to kind of go from 0 to n or 1 to n or whatever, or you could go backwards, go from n to 0, right? Either way you write the loop, it doesn't matter. It gives you the same answer, right? I mean, of course, if you write it in one specific way, it actually, you could generalize a little bit better, but that's another story. But given one input, one dynamic programming solution, it doesn't matter which way you go, right? Like go from 1 to n or n to 1, right? So that's what I call a symmetric dynamic programming problem. The thing is that, and it just lets you get sloppy with, +1 or -1 indexing and stuff like this, because it works in both directions. You could think about certain versions of shortest path is the same, right? Like you could go from A to B, and B to A is the same. Like the edges are the same, so all the weights are the same. So it doesn't matter. But that's not true for dynamic programming, right? Always, which is why I bring it up. What I mean is that certain dynamic programming problems, you have to go in one direction. You cannot go backwards, or like go forwards. I mean, you could write it so that you go in the other direction for sure. Some stuff about memorization and bottoms up and stuff like this. But even then, the ordering matters, that you have to do it in a certain way, right? Like whether you do pull or push or fetch or whatever, that's more syntactic versus like how you think about the problem, right? And I want to bring this up because I think this is one of those problems where it applies, because if you think about it, there are two ways of just from experience, I know this dynamic programming, even though I don't remember it, and a quick glance at n is equal to 100 confirms this, right? Because what does n equals 100 means? I mean, maybe it doesn't confirm it, but it at least means that a dynamic programming solution is viable, and it lets us, with 100, it roughly lets us do n cubed stuff, which should be, a very naive way of thinking about it, and maybe there's a better way, but it's just that there are n square substrings, right? And if we do all of n operation of each of those substrings, that's n cubed, and that will be good enough. And that's, you can see that they're all easy, not easy, but for this one it won't be easy, probably not. But you can see that there are solutions in which, n cubed, like, should be gettable, right? Like, we should be able to solve it, or with enough experience, etc., right? But yeah. So there are two ways of thinking about this in terms of symmetry, right? One is, let's say we start with an empty string and we're trying to print to, whatever the input is. So we're starting from an empty string up, and then like draw or print the whatever at any time, right? Or we can start with this, the input, and then kind of erase characters along the way, so that to get to an empty string, right? And depending on the problem, it could be one or the other, and maybe even sometimes both, depending on the actual problem. But for this one, maybe it matters. I think that's the thing that I have to think about. Okay, so this is all the setup I have for this problem that I'm familiar, that I just want to bring up before we solve the problem. And the reason why I say it like that is because now the hard part, now we have all these ideas, or at least the foundation for the ideas. Now we can actually, attempt to solve this problem, right? And that part, honestly, I don't know if I know how to do it, or not that I don't know how to do it, but it may take a while, honestly, because I don't know. Maybe this is one of those like mental bias thing where I'm like, I do regularly have ideas that it was hard, so like so it may take a while, but we'll see how long it takes. But I just want to get all the setup in and all the foundational stuff, and hopefully that makes sense. If you're still watching and listening to this point, leave a comment about symmetry and dynamic programming so that I know y'all listening. Otherwise, maybe next time I just don't talk about these things if it's not useful for people, right? Because I think, and the reason why I talk about stuff like this is just because anyone can go over the solutions. Like, we can click on the solutions tab, we could read it, and maybe I'll even draw it out and pretend I understand it. And then, that's how most videos work, right? On YouTube's. But I want to be different, and I want to actually show you, or at least give you my perspective of my experience, right? I mean, why do the same videos that everyone else had already done. I don't know. Anyway, okay, so let's see. So as we said, there are two ways to think about it, or at least two starting ways, right? Maybe there are more branches along the way. So yeah, and kind of the thing that we have to do then, right, is that yeah. So that now I'm going to think about how I want to think about this, right? So let's say we start with an empty string, right? And then here we start with AAA. We could do AAAA, BBBB. Yeah, I think the thing is that it is definitely tricky. I don't know, because the case I'm thinking of in my head is something like something like that, right? And then the question is, how many strings do you want to do this? Because this could be just, you know, I mean, the actual answer doesn't matter, or for now, but it's just about how we want to attack this problem such that it's reasonable. Like you could do it this way, you know, something like that, and then whatever, right? Dot dot dot. You get the idea. Or you can maybe just do it like all A's, and then one B, right? So forth. Also dot dot dot. You get the idea, right? And which one is cheaper? Well, this is why we do dynamic programming, so we could kind of try both of them. But then the question is how to set it up so that we are able to do it, right? I think there is a quick idea, some observation, right? And this is part of what I said about greedy, in a way, to kind of get some more performance. Like maybe it's not necessary per se, but is that given a substring that we want to color, we always want to color the first character and maybe the last character, but I don't know. Do we need to know the last character? I don't know. Or like, what I mean by that isn't that we don't need to color it, but it's just that it may be a sub case of the other thing that I mentioned, which is the first character, right? But yeah, for given a substring, you always want to at least color the first color, so that makes our decision easier. And the reason why we do that is because if we don't do it, then we have to do it another time anyway, right? So, and also it gives us a easy DAG in a way. And what I mean by that is that it's never going to be acyclic. It's always going to be acyclic because you always at least make one improvement, right? So that you never get the same substring twice. And also that means that the max answer is going to be n, to be clear. So maybe, you know, we would have something like paint, or what's it called, min paint or whatever, I don't know, paint min. So left, right, and we want to make sure that we define these, you know, as we like. I always like to make them inclusive, so left, right, inclusive, and this is to minimum to print left, right? Yeah. And maybe we just have if left is greater than right, then we just return 0 because we're done. If left is equal to right, then we can also return 1, though. Though it's not as important because I think if you, or like it's not as important as a base case because you can probably generalize this a little bit. But for now, we'll just leave it in just because, I don't know, why not? It's not a big deal. It's a very cheap operation, right? And then now, then the way that I would think about it is that given this input, right? We could delete these for now, I hope. Otherwise, I might have to draw it again. But the idea is that, okay, let's say we have A, right? So then what are the solutions, or what are the sub-problems here, right? So we would color A. So then one sub-problem is that we drew 1A, and that's it. And then we have to solve this. And then another is going to be, or maybe I'll write it like this. Right, and then another is AA plus this thing, AAA plus this thing, and then AAAB. How do I phrase it? I mean, it's not quite precise, because I think here you can. I don't know how quite precise, because I do want to make it something like this, but not quite this, right? Because we know that you know, the prefix is not going to be this. It is already going to be a thing, so it's just going to be kind of like this is the actual solution, or maybe something like this actually, right? But that's, even though this looks a little bit tricky because there are 3 things, and you could kind of factor that in as to the cost of here, and just on the left side, just kind of handle the left side a little bit differently, right? Because you never need more than 3 pieces if you want to count it this way, and that's fine, right? So it doesn't like degenerate, because this is just a prefix. But if you just want to count it on this, then if you do the cost of this, then the recursion would actually be f of b or something, right? So then yeah, so I think this is probably good, right? Because then here, right, is also just I think this is the part where it gets a little bit tricky, right? Because here, I think the right part, we use the A, because the left part is what we paint A to after, right? And then the right side is, you know, the rest of the stuff where it could be A's, doesn't have to be A. But on the left side, everything is A. But then now here, so I was hand wavy a little bit on this side because it's a trivial case. Even this side's a little bit trivial, but maybe a little bit less so. So then now, because I think this part, because you cannot do it in a function, I think the idea may be just to, but the thing is that we do know the cost of B. So maybe we have to figure out how to add an additional thing. Because basically the idea that I want to convey, and this is probably the tricky part that I probably struggled with in the past, the idea that I want to convey is that we get this A for free, right? Because let's say we just have this thing, and let's say we just chop this off because it's trivial. Then now, if you don't take account the fact that the A in the middle is for free, then now we have B, you know, we have B plus A plus B, but the middle part is not, whether it's free or not, will take an extra turn, right? Hopefully, I mean, I don't know that I'm explaining it, or I don't know that I'm saying it quite precisely, but I hope that you get the idea in either case. So then now I'm trying to think about what is the best way to, you know, think about this. Like, is it to have a free character? Right? The thing is that if we are able to have a free character, it's actually pretty cool too. But I'm trying to think through all the cases of what that means, right? Because if you have a free character, then actually you don't need to do this loop, right? Or you don't need, another way of thinking about this free character is that, you know, maybe without the free, what I was thinking of is something like for I in range of left, right, maybe right, either right or right plus 1, but this pseudocode for now anyway, right? Then you do like something like paint min, I left, plus paint min, right I, but of course we do something progressively, like, you know, this isn't quite the paint min because this part has free, so we do some maps, right? But if we are able to have a free variable, right, then now instead of, you can think about this as what I always call unrolling the loop, which is then now maybe you can rewrite this in a way such that we just take the first character and then the rest, right? So then this is free A plus the rest, and that already and as a result, this free A plus the rest, you know, and then it just becomes tick no tick, right? Because then now your question is, we either use the free or we don't use the free, right? And I'm also trying to think whether I need to, in this case, the right element. I guess we do. This is so hard. So I don't think that this is enough though, the free thing. I'm like, this is an idea, but I don't think that's quite precise, because you can imagine you have free A, right? So then now you can't just do tick no tick, because now let's say, you know, we remove the two A's, and then now we have free A on this thing, right? This is the input. How do you get it so that here only this part is free B? So I don't think you can do a tick no tick and then the rest is going to be free A, right? And I think for this you definitely need a loop, right? Even with the free variable. So that's why I was trying to see if I could eliminate the right thing, but in this case, you know, you think about free A plus AAA plus this part plus this part, right? And these two free A's are the same, right? Like they're part of the same one turn free A. And I don't know. And I want to say that like a more naive way of thinking about it, maybe. Or like not naive, but it's just like a different dynamic programming problem that you may ponder, is that, you know, I think the more easy way, which I probably skipped because I don't know, I just didn't think, I thought maybe I could think of this but on like this. The easier way is that for here is that we actually you know, so given that this is the input, we have to take the first character. We can actually you know, just divide it for every substring. No, that doesn't even work, right? Because you can imagine, let's say there's a lot of A's in the middle, and then another series of B, right? Because then now you want all these A's to share, but you actually have two distinct B's, right? So you have to figure out a way to, like I said, this is hard. I still have not gotten this far, that far, right? But it is good practice. So hopefully I'll do this in a little bit better. But yeah, because the first set of B's and second set of B's are going to be different, right? And we want to, so you cannot just like chop this off and then be good. You have to figure out a way to chop this off and this off in a good way. And I don't know if free is a good enough way to handle that. I think there is another loop that I have to figure out how to unroll. But you definitely need a thing that there is an idea here, but I don't think I remember it in a good way. But basically the idea here is that yeah, for each, like even if you look at this just as a chunk, then the idea here is that like we take well, probably this A, but like we do a recursion. Well, we get rid of the prefix A's, which is fine, and then now I guess that's fine. I think I just get confused by the prefix A's. Or I wouldn't generalize too much. I think if we chop off the prefix A's, right, then now we can divide this as this plus that, and then as a result, and we pass in the free variable, and if the variable is free, then we can also chop this off, right, and then just do a brute force iteration on here up to whatever. I mean, even up to the end, really. But then just chop off the rest, right? So maybe we can do it that way. And I think maybe the prefix was throwing me off a bit, because I was trying to generalize it with the A's and the B's. But I think you always remove them. Okay, let's think about it that way then. Yeah, okay. So then here, okay, if the first character is equal to the free one, we just chop it off. I mean, we can also do it with a for loop. Not really a big deal, but you can always write if s of free, or no, s of left is equal to free, then we just return paint min left plus 1, right, free, right? So this part makes sense, right? So okay, let me actually try to explain it quickly. And the reason why is that we basically want to do a loop on where the second drawing is, and then do recursion on the rest. And the rest is assuming that we want to continue the free character that we have. So that part is the tricky part that I think always takes me a while to understand. But yeah. So okay, so the first character is equal to the then we chop it off. Okay, so that's good. Otherwise, if it's not, then we either if it is not, that means it's time to do a new one, a new series in the middle, right? Because now, let's say, I should have the original one, but it doesn't matter. Let's say we have something like this, right? And that's why I always write these out. I mean, back in the day, I had a notebook and I still use it from time to time when I really need to dig down. But of course, I'm doing it on these ASCII art, so you could see how my thought process. But yeah, but the idea here is just that now we already chopped off all the A's, and then now we're brute forcing where the A's are continuing, right? So now we're getting free A, or printing A. And then now we're chopping, you know, maybe it could be here, for example, for some, like if the input. So then now the rest of it, and actually in this case, it includes all of these, are going to be assuming free A, right? So it's free A plus here, and then the substring. The hard part is that there is a loop unrolling here that we might not be explicit about, is that we just basically want to continue this loop of free A's. Which is how, because then now in a recursive kind of way, you know, all this stuff will be good, right? In continuing the same free way. So then now here, yeah, new free is equal to s of left, right? So then now we have for I in range left, right, probably right plus 1, I want to say, right, And then now, oh yeah, of course we do a best. Try to minimize, so let's just say best is equal to infinity. Right? Okay, yeah. So then now, right? So then now we want to say the left part is. So now the left part is the part that does not contain the free A, right? It contains the new free character. So then now we want best is equal to min best. So the left part is going to be paint min left to the I inclusive, right? The free is the new free, but then this is +1, right? +1 because we assume that this new free will be the new set, and of course that also does not include this thing, by the way. Though maybe you can, but I don't know. Maybe it doesn't matter. Well, it does, but in a way, but you can make it not matter. And then now, so this is the left side of this substring plus paint min I +1, right? And then the same free, right? And that should be good. I hope, I think. Oh, this isn't true. If left is equal to right, then it is actually, it should be if free is equal to s of left, then return 0. But I think you can actually, like I said, this is even, sometimes this is why having a base case is worse than not having one, because you can actually delete it and it'll be handled as part of this function, I suppose. Yeah. And then now we want to say return paint min from 0 to n-1, keeping in mind that it's inclusive, and then we just have an empty character. It's fine. This may or may not time out, actually. Okay, well, it doesn't time out for these inputs. So yeah, that's basically the idea. But like as I said, this is very difficult. And of course, I would also say, just to be clear, even though we do a free variable here, you can also think of, like, there are a couple of ways to represent this, right? So let me write it out real quick. Free is the character we get for free, but you can also imagine like the leftmost or something like this, and then free is equal to s of leftmost. You know, that's another way of saying it, which is the leftmost character that you start, so then you have this thing. But technically, this is probably, I think they should be the same, honestly. No, I mean, I think this is strictly better, or strictly or equal to better, because, you know, they're all going to be the same A, B, C, right? So okay, so yeah, so let's set that up. Yeah. Yeah, this is gonna be what I usually. Sorry, I'm like deep in thought. But what I always say is that this is gonna be too slow, right? So we need to memorize it. People ask me why I write it out in these two ways. I don't know. I mean, I just think that this is a little bit clearer. You don't have to agree, right? But maybe this time I'll be a little bit lazy though, because this is already a long video. I'm not gonna go over memorization. If you want, I talk about memorization pretty much every daily problem that has DP. Even yesterday's, if you want to check that out. But for now in Python there is this cache thing, and what it does is that it changes these three keys and the parameters into a tuple and then put it in a hash table. It does a little bit more than that, but that's the general idea. However, the thing is that you have to, the caveat about using it like this is that it is generally slower than putting it in an array. But yeah, that's pretty much it, I guess. So let's give it a quick submit. Hopefully I don't get this wrong. Or maybe times out. Then we have to think about another way to Oh, it does time out. Last time I did a little bit better, I suppose, a year ago. Why does this time out? Actually, it's okay. I guess there are just enough cases. 190. So, okay. So, I mean, now we have to make a little bit of an optimization, right? It's either that or we might have to, write it bottoms up, which is not that bad, but I mean, at least I think this is correct, though. I mean, the way that Leetcode does it is not always true. That no, because the timeout comes before they get all the answers. So sometimes it might not actually be true that just because you time out, it is correct. That's kind of it's vaguely surprising, but because this is the reason why this is surprising. I mean, and you can see this, right? I think this is 100 characters, probably 100 characters. It's a little bit surprising only because okay, let's do the analysis real quick, right? I mean, I did it off my head, but this is going to be 100. Oh, sorry. Analysis is such that left goes to 0 to 100. Right goes to 0 to 100, or technically left to 100. 3 is just 26 characters, right? 27 if you want to count the empty string. I'm trying to just like see if I'm missing something weird. Left is going to be yeah, I don't think I'm off by 1 or anything. Why is it timeout? But yeah, as a result, this is just, and each of these, so we have 26 times 100 times 100 inputs, and each input does O of n work, or 100 or 100 up to 100, right? But if you also like look at how the substring stuff works, I think it's like it's n choose 3, right? Is it? Am I making that up? Either way, it's like, you know, but I guess the 26 makes it kind of expensive. That's the thing with Leetcode sometimes, is that I'm trying to think whether it's like, can I do a small optimization or do I need a big optimization? Because Leetcode is just kind of bad on differentiating. Hey everybody, this is Larry from the future of the live part. I just want to cut in real quick, just so that you don't kind of see the future a little bit. But you can watch it. I want to say that I actually go over it a lot in different ways, and wondering why, you know, certain things are the way it is. And I did a long exploration. So we do want to see the live portion of it, go up to that. So where I cut in should be about when I got this time limit exceeded. So I got this time limit exceeded. I'm like, that is weird. Or I don't know if it's weird. It's just, you know, at this time, I thought that, and I talk about this anyway, I thought that, you know, I'm not sure whether it's a Leetcode issue or a Larry issue. With time limit exceeded, it's not always clear. But here's where I'm going to cut in. So here it turns out that this code, and I explained it a little bit, this should be O of let me actually copy this so that I could actually edit it real quick. Hang on. Right, so here, just doing a quick analysis. Right, left could go from 0 to 100. Right could go from 0 to 100. 3 can go from, you know, A to Z, and also empty space, so maybe 0 to 2, 26 of these, right? And of course, each input takes O of n times with this loop in the middle, right? So, or up to 100. So this ends up being O of n cubed times alpha, right? Which is going to be too slow. So, but it turns out, and as it turns out, all we had to do is just do an if statement. If s sub I is equal to 3, then we do this. And you know, if I talk about it during the video, I said that we're just chopping it on the left side. So the left side, this is the 3 part, right? And the right side, we start on I plus 1 on the new 3 thing. So then maybe we can write it such that, yeah, wait, how did, I'll just make sure I get the, okay, yeah, it's fine. If I add this if statement, that means that s of I is equal to 3. So this, we can just go from left to I minus 1 because we know it's going to be equal to 3. But the left side is still going to be using a new character and the right side using the 3 character, right? So we run this. Oh, yeah. But now that we have this if statement, well, it may never happen. So we have to do the base case a little bit differently. And if there's no if statement here, or if this statement is never true, that means that the free variable is not from left to right. And therefore, we need to add something like this. And then we just paint min left, right, new 3, right? And of course, this will require +1. So basically, we just don't do this part. We only do the left side, assuming that it's left, right, +1. And run it real quick, submit. And that's all you need. So apparently, that's all you need, this if statement. And of course, following through the if statement by changing the base case or one of the cases a little bit. It's all you need to get a time in, right? Well, not a timeout anyway. I don't know if it's called time in. But yeah, and the reason is a couple of things. I actually talk about this at the very end of the video, so that's also like a long time, so that's why I kind of reiterating it here, or for you the first time. So here, where if s sub I is equal to 3, then let's analyze this code with and without the if statement, right? I actually wrote it out, so actually let's just use this. Let's analyze this with or without the 3 statement, right? So, without the if statement. So without the if statement, we have this thing, right? And I actually, this is wrong. This is just the number of states. But, yeah, this is just the number of states, by the way. So you have to times an order of n for time. I don't know if I mentioned it explicitly, but yeah. So basically here, let's say you have to, without the if statement, the free variable gets passed down everywhere, even in unnecessary places. So let's say you have A, B, C, D, E, F, G as the input string. If you look at just the right side, let's just ignore this for now because it doesn't matter. If we look at just the right side, let's say we paint min 1 and 8 and the free character is A, and then you do another level of recursion, and we only look at the right side again. So paint min 2, 8 is going to be A, ... and this just means that the ... also, you know, print up to like 8A with A or something, right? Or up to 9.8, I suppose, and then it returns 0, right? So that's where without this if statement, that's what this does. And what this means is that it makes this quote unquote a hard n squared times alpha, because we also do this for B. For this input, we also do this for B, we do it for C, ... So that means that for each substring, for each input, for each combination input, 3 is going to be all the unique characters, which in the worst case is going to be n squared times A number of inputs, which makes it all of n cubed times A time, right? Don't talk about this at the end, so I don't know. But with the if statement, this becomes something much faster. With the if statement, then now there are 2 cases, right? S sub left is equal to 3, or S sub left is not equal to 3. And yeah, just ignore this part for now. But what this means is that for every left index, when you just look at left and 3, then it is either equal to 3. If left is equal to 3, then it is intended. So if left is equal to 3, there's only one case that it happens, right? Only one scenario, which is that, well, they're the same characters, so it means the same thing. Or it can only be one character because of this if statement. Because of this if statement, that means that well, s sub I is equal to 3, so s sub I plus 1 maybe don't equal to 3. So that means that if we the input here means that s sub left minus 1 is equal to 3. But that also means that there are only two possibilities, right? Because that means that this 3 character has to either equals to left or left minus 1. So then now, this is the number of inputs. And here it becomes n cubed times 2, if you want to write it that way. It becomes all of n cubed time. Which is, of course, if alpha is 26, then this is, I don't know, 13 times faster if this gets called with 2 numbers, right? So that's basically the reason why this is so much faster versus the other one. And also it tells you, and this is why it took me an hour and a half, because I was trying to figure out how to write it in a cleaner way, such that we embed more information. And I did come up with another solution, and if you kind of skip ahead a little bit, fast forward, you'll see how I came up with the other one. It's kind of fine, you know, it's good, it's fine. But even that solution had the same issue with this free thing. And then I kind of went back and revisited why, or like I was trying to work backwards to really understand the problem. So that 1 hour and a half is me trying to understand this, and yeah, and basically this is the conclusion that I came up to, which is that this if statement is outrageous in what it means, and that was what I finally understood after an hour and a half of studying and understanding this problem. Anyway, that's it from the future. You could keep on watching. There's more live recording of me coming up with this. Maybe it's interesting, maybe it's not, but you can, yeah, I want to just put some emphasis on both the grind and also just, you know, it's not enough to get the right answer. You have to understand, like for me anyway, it's not good enough for me to get the right answer. I want to get to a point where I can get it again, right, and understand it again. And I think like it's very easy in a parallel universe. I write this if statement because it just seems like an obvious optimization, like or not even like an obvious optimization. Like I thought it would make it slightly faster, but until I analyzed it, I didn't think it would be 13 times faster on it, or O of alpha times faster, honestly. Because I thought it would be a little bit faster because, you know, you save time on some recursion or whatever. Like, it's fine. Like, you know, and like I was saying, it does actually get terminated. So it wasn't like a correctness issue, right? But until I really analyzed it, there was an O of alpha constant that, you know, maybe the last time I solved this, I probably just put it in here because it's just like a easy thing to put in. And this time, it wasn't that I didn't think about it. It's just that I didn't think that would do anything. Because I did think about adding it. I was just like, it's just more to explain. It's fine. Like it should be equivalent with or without it. It's just that, you know, maybe because a lot of times in dynamic programming, even without these filter if statements, you just do like 1 or 2 more recursive step, and then it just, you know, like it doesn't add to the time that much because of that reason, because it just does like 1 more recursive step, and then there's like an if statement that gets filtered out. And maybe that experience kind of biased me into not doing this if statement because I don't know, I was just too lazy to explain it or something like this. And then I really had to dig deep into why this if statement changed. I even thought initially that maybe the Leetcode inputs made it easy to do it this way. What I mean by that is that like maybe the Leetcode input was specific to some test case in a way that made it fast enough, but not for, you know, without the if statement. But then when I really analyzed it and trying to understand it, I was like, oh wow, this is actually it is a whole O of alpha faster as a result. So yeah, and one more additional tidbit is that if you look at this code, it is, you know, without all the Larry comments, it is like 10 lines of code. You add an if statement, it is you know, one line of code in a 10 lines of code. And if you look at the solution with the if statement or without the if statement, it would look good enough, right? But this is why you need to figure out how to problem solve and try and analyze and just analyzing the having the tool to analyze and practice that as well. Because if you look at someone else's code, you know, maybe the if statement's obvious, maybe it's not, but maybe you would not and you know, intuitively, like I said, you imagine it to be faster, but maybe you wouldn't imagine it to be all of alpha times faster, and I certainly did not. So you know, maybe I cannot speak for everyone, but that's just me. Anyway, the reason why I did this kind of interjection is because hopefully it is useful. So because it is definitely like new to me in a kind of cool and weird way. So yeah, that's all I have for the interjection. Anyway, go back to Past Larry now. Boop. Okay, let's just actually write it out then. Maybe this will be better. Because I was just a little bit lazy, as you know. Oop, why would I write it that way? I think I did this wrong. Oh yeah, the reason why I wrote it this way is because I was lazy about converting. Anyway. Right. And the reason, and people ask me why I have two things, is so that I don't have to, because you can write it in different ways. You could write it in that you only have one of these variables and not both, but then it's just implicit, right? Which is fine, but I like to have it explicit. I'm trying to think like how do I memorize the first one? Yeah, well, I guess we can. I guess I don't have to do it this way anyway. This could be s sub 0 plus 1, which is fine. Oops. Also, I didn't actually cache. Oh. What? Oh, oops. Silly. You can see that this is 6 times faster, right? But wrong. Do I have a typo somewhere? Huh. I mean, faster is good, but not if it's wrong. It was right before, right? Like, I wasn't enough dreaming. This is good, right? Huh? This object not callable? What does that mean? Oh, because I used this same variable name. Oh man, this is annoying to debug. I just want to see whether like, okay, so it is giving me the right answer, except for when I cache. Oh, this is, I'm dumb. This is free. Okay, there we go. Wow, this is slower by a lot. Huh. Well, at least that's good. That at least this is right. But slower by a lot for some reason. If I have to guess, it's probably because of this allocation of time and space. Like for example, if you, well, maybe we just get rid of has cache. Let's take a look real quick. It's still pretty slow. I wonder if it's a time thing. I'm actually kind of surprised. Usually, if you write it out, it's faster. Am I just... Am I dreaming? Yeah, I don't know. That's weird. I mean, this is a little bit... This is definitely faster than having the cache. Now I'm surprised, to be honest. I mean, I know that there are some stuff around, you know, like write is actually not technically 0 to 100. It is like more 0. But I can't imagine it'd be that bad. But yeah, okay. Well, this is good, I think. And really, everything gets rolled anyway, so... I mean, I think this is also like one of those Leetcode things where I have to make like a silly optimization versus like a real optimization. So I'm trying to think about how much work I want to put into this. Because I think this is right, honestly. I don't think that I'm... If left is equal to I, then what happens? Then this should happen, and then this should happen, right? So I think we're good. It's just like 2 more function calls. It's not that bad. So I don't think we're doing like an infinite loop thing. I don't know, to be honest. I mean, I could write it bottoms up, but that's just like annoying. Okay. I mean, I guess it is what it is, right? I'm just trying to see if I need this free character. I mean, we could still do this like divide and conquer DP. Can I write this in the other way, maybe? This feels so much more natural, though. How would I get rid of this free? I guess this is, I don't know. This is a little bit tough because the one reason why it's tough is because, when you have an answer and you're like, well, now I have to make one more optimization. I'm trying to like reset everything in my head. I think I have to get rid of 3 somehow. I guess 26 million is just barely too slow. I mean, I think also like if this should work in like another language also, honestly, like Java or something, but Python is a little bit too slow. So I'm trying to think how to get rid of the 3, right? So okay. My watch keeps on pinging me. Oh, I guess my phone keeps pinging me. Oh, anyway. So we have something like right. I think there is like a thing where you embed the costs into things, but okay, let's say we had let 3 is maybe another way to think about it, but in the thing that we said if it's the left character, right? Let's say with the left character here or left index that we're trying to match, right? Can we somehow embed that into the left? Okay, so I mean this part, it's a little bit awkward, right? Okay, so let's say we have A, right? How do we divide this? How do we divide the rest of this stuff such that we respect the A part? And we're only given 1 loop, right? And this is kind of like working back from the complexity, so it's a little bit cheesy, but yeah, so we're only able to get 1 loop in. So let's say we arbitrarily do this, right? Now what does that mean? Right. Okay, so then the left side, don't even know how to reduce this. I mean, maybe we don't need this anymore. That's why I'm like stuck here. But okay, so then now, yeah, and I thought I beat it this time too, but yeah. Then now, and let's say it is an A. Right, so we remove the first one, say. So then what do we do on the left and the right to kind of maybe we skip the thing about first character being free. Right, okay. So then now, how do we do it? Divide and conquer. Okay, so let's just say we divide and conquer these things. And then so then there is a barrier here, right? And then you just kind of recursion. Unless, what is the unless? Well, oh, I see. So then basically now we're saying, okay, the rest we just do, and then this part is going to be one color. And we color, I think the cost, we have to change the cost. Right, and then the left. So then now we're changing the base case instead, maybe? No. Okay, so how would that look? Something like this. Right. And as we said, this has to be the same color as the first one. So maybe like if S of left is equal to S of I, something like that, and then maybe that even makes sense. I don't know, probably not. Okay, I think I get it. So then now we just we have to paint the first character, right? Okay, so we're painting the first character as we said, and we're trying to paint it to a thing, and then some of it we divide, and if we divide, then we keep things to the right, and we're only going to go. Well, I want to say that it only matters if they're the same, but I don't even think it does. So then now we go right, and then here. Oh, well, I guess in this case, if left is equal to right, we just return 1. But then, okay, no. And then now we subdivide. If s sub left is equal to f sub right, then then we can also chop off at the end, maybe. And then it's just best plus 1. Because this is still assuming that we print on the first color. And this is harder than I remember it. Oh yeah, this goes to infinity if I don't do a left is equal to right. Oops. How does that be infinite loop? It's just that this goes first, because this is always I. Huh. And stumped again by this far. Okay, so we try and print min from left to right. Right? How do we do? So here we do a loop. I mean, I think this loop is kind of right. Or whatever. But well, maybe not because of the infinite loop. But I see it. But it's so hard. For me, actually, I see the solution now, but I'm trying to understand how to come up with it, right? Other than just practice, because practice is fine, and you get an idea, but I don't want to memorize the solution. I want to actually learn how to kind of come up with this loop, right? Because what I did before actually also makes sense, even though obviously it's a lot slower. But the idea here is now doing it in reverse, right? So then now we chop off here, and then maybe we do another chop off here, and then chop off here, or in A's. Well, maybe this, and then we just kind of brute force it this way, right? Well, not brute, yeah. But that's so hard. I'm trying to better intuition about it. That's so you have something like And then it's just like something like this. Right, so that if it's I, then you replace it with 1, which is I guess what this is anyway. So maybe I don't need this. Oh. Well, I guess I do, just because I think this is kind of right, but this goes in an infinite loop. Wait, what? No. Wait, is this right? Why is that? Goes left plus 1, left plus 1. This should only... This should only go up to n number of these, right? Why is this infinite looping? This is plus 1, this is plus 1, this is plus 2. Wait, why is this infinite loop? What am I missing something? Alright, let's print it out real quick. Four, 5. Okay, so 4, 5, it goes to okay, so 4, 5. So this goes from 5 to 5, right? So then now 4, 5. Huh. Oh, so I'm just terminating in a dumb way. How do I fix that? I'm today is one of those days where my video is an hour long. Okay, so let's go through our process again. So we want to basically do we do this loop forward, but basically we chop off the rest. We don't care about it anymore. The left is what we care about, right? Okay. Because here we can, it doesn't matter. That's basically our idea, is that it doesn't matter, and that this part is fine. And now we have this part, and then we slowly also chopping it so that it doesn't matter. But then the I thing is a little bit weird with the And this is still giving issue with 4, 5, right? So 4, 5. This is 5, 5. That's good. Oh no, because 5, 5. Well, 5, 5 will just give 6, 5, which returns. So then, but then now it goes 5, 5. Actually, this still also returns. But then now we have 4, 5. I just put it out, so I think it's 4, 5 that's stuck though. But why is this stuck? And usually this happens when your DAG isn't quite a DAG because you're not, yeah, you're not making progress like I did the other time. Okay, so then now here, what does 4, 5 mean? 4, 5 means that I'm trying to solve these two, say, and then I'm trying to, okay, so that means I have 2 characters. It really is what it means. And then now I'm trying to split on, so left plus 1. So I split on 1 character, right? So that means that well, if this is 5, 5, then it does not range. Okay, but then you have 4, 5. You have 1 character, right? And basically 4, 5. This course. This is 5, 6. So then this is a 5. So then now it is splitting it from the and an empty character. So that's definitely wrong. Maybe we want the right to have 1 character, maybe. No, I don't know. I think this shouldn't be wrong, but we definitely want to remove 1 of the characters. Okay, I guess this is the thing. So then now we don't need this, maybe. But now it's wrong. Yeah, okay. But yeah. Sometimes I guess you have to visualize it. I think I wasn't visualizing it because then now we have 2 characters left. We must split into 1. Though there is also a thing, maybe we want to split into nothing because in this case it should be nothing, which is why we are having costly situations. And the comment is no longer true. I'm not passing the cost very well. I'm passing the free bit in a good way. The idea here, okay, what is the idea to get a free bit? Maybe something like if s of left is equal to s of right, then we something like that. Oh, because then now you never code this part. So maybe now we need left is equal to right is equal to 0, 1. Yeah, YOLO, let's give it a quick submit. This is kind of hard. Yeah, I mean, I think this is a separate technique. We'll go over it in a second. I'm just catching my breath a bit. I mean, we've been going at it for an hour and 14 minutes. So of course we get rid of the 3. So this is only, n square input, another n, so there's n cubed, right? And you can actually, do the hash cache thing and put into arrays. Just to kind of illustrate it, just do it really quick, so you can kind of see the performance benefits. Sometimes it doesn't though, I don't know anymore, but so I'm a little bit tired, so I'm not like, yeah, so something like this, right? But this is a very hard loop to write, honestly, or to unroll. It is another way of doing loop unrolling, but it is definitely harder to do it this way. I'm curious whether it's faster. Apparently not. Usually it gets fast. This is my experience, but so don't take it as a whole. For 100 square, it's fine, but once you get to 1,000 square, cache gets really slow because it's like log n or something, right? But except for that adds up, so that's why you want to do it that way for n is equal to 1,000 and stuff for n square. But in any case, so this is basically another way of unrolling, because I was thinking about rolling it forwards, like the way that I had the free variable, if you kind of recall from an hour ago, is that we basically want to divide these things and then kind of keeping the free bit, right? But here, in a separate way, and the free bit allows us to kind of just do whatever on the right side, but then here we just assume that given the prefix a, which is subtract, then now we do, solve its own subproblem, right? Which is fine, and it worked. It's a little bit slow, but it worked, right? So then this new loop is just actually, we cut it off for each one we brute force. Okay, what if the current thing is here, right? What if this is the loop? What if the right side is the stuff that we don't care about, and we literally don't care about it, right? It goes to the right, it can do whatever it wants. So we only care about the left as a recursion, right? But as a result of that, that part of the loop is easy to understand. But then as a result of that, the difference is that the cost of calculating this cost is a little bit different, right? And that's where and then here we also chop off, like, okay, let's also keep on brute forcing, chopping off the right that we don't care. So, but in this way though, right? If you have this loop and this loop with these indexes, then what you're doing is actually, and I talk about this in an easier problem than this one. So this is why I was like, whatever. Another way to think about it is that, like, if you want to think about what it is doing, is that it is essentially doing all, roughly speaking, all 2 to the 100 loops, right? Because basically if you have, I don't know, I'm just going to use, okay, fine. Let's just use, I'm banging on the keyboard. It doesn't matter what I'm typing. But the idea here is that, okay, the first loop, we will create a thing in the middle, and then keeping in mind that everything to the middle and to the right is recursive, right? And then the second one, we also do a combination of so let me start again. So one recursion deep, keeping in mind that we're trying to brute force. Okay, I'm counting it backwards in a way, but you could just do like brute force of this and brute force of this, brute force of this, brute force of this, right, and dot, right, all the way through. And let's just say we up to here, and then we do, and we don't care about the right, as we said, because this is they're both its own subproblem, right? So okay, right. So then now you have this, and then now again we have this. So in a way, it means that for every space. So for every space, let's call it. It's just hard to visualize a little bit. Maybe I'll draw it out. I think maybe drawing out is a little bit better. Let me draw it out, because I feel like the ASCII artist leaving me a little bit behind. This is an annoying thing. I mean, this is definitely like a way to do it, so it's fine. I just the hard part is coming up with the cost function, because the other way to do it, the cost function is kind of built in a more intuitive sense, if you ask me. But yeah, so kind of to see what this loop, the loop and the recursion is doing, you have basically like I don't know. I'm just keeping it the same. That's actually not right. I don't know. Whatever, right? And now you have, keeping in mind that you have all these spaces in between the characters, right? And then we ignore the last one and probably ignore the first one because it just creates a trivial empty string, which is why we had infinite loop anyway, right? So then now the first loop we will put, it's just about putting a divider up here, right? And then the second loop is just maybe we will go put up here or here or here or here, right? And then let's say we end up having it here, right? And of course the left is still going to be, the same, right? So then now we're trying to solve here on the left and here on the right, right? But as a result, that means that this wall is up, right? And the way to think about why this brute force work is just that if you look at all the spaces in between, then we are literally brute forcing whether there's a wall and there's no wall, right? And as a result, you have like a 2 to the n type thing, which is all the possibilities. So we are enumerating all the possibilities. So that part hopefully is pretty straightforward, or at least like it comes up a lot. So that's why like I was able to kind of come to it and then work backwards from the complexity that we need for this problem. How did I solve it in 395? Did I do it bottoms up? Maybe I did it bottoms up. Like it's usually, we'll double check in a second. But yeah, and then now the cost is just that, again, we're trying to print the left side, right? Yeah. And the reason why we had to write it this funky way is because we're trying to embed the idea of using what is the variable that we get for free, right? And the thing that you have to get for free is keeping the idea that we always print the leftmost thing, right? Which is what this thing here. This actually does the printing. It's like, okay, we're done. But then here, we basically keep track. We keep the same thing that we're printing, but we remove one thing because we print that one thing to the right, right? Because that's the last thing that gets printed. And of course, if s to the right is not equal, then it gets part of this loop anyway. So if you think about like a case maybe like like AA, a bunch of stuff, AA, then now what happens is that, okay, this part will get rid of the suffix, and when s sub left is not equal to b, then the for loop will take care of it by and keeping in mind that this part is still the same, but here it's just going to be chopping things off. So then you're brute forcing, putting a space here, putting a partition here, putting a partition here, dot, right? And then in that way, you also keep track of A by putting it in the, or you keep track of the A, you still haven't removed it yet, because we're still printing with the A by removing it. It's kind of really tough, because this is kind of goes back to what we were talking about with symmetric and asymmetric. In this particular problem, it is symmetric, right? Because you could, or rather, the setup is symmetric, but the functions are not, right? Because here, you could recall how we could even pull up the code, really, not just recall. You could see that here we do a first character, we just chop it off, right? And we're good. But then in chopping it off, you could think about this free variable as keeping track on the left side, right? And in here, what we want to do, maybe we can even play around with this a little bit, honestly, now that I think I have a slightly better understanding of this. So keep track of this. For those of you who just want to look at the correct solution, keep track of this real quick. But yeah, let's say we have this, right? And now I'm trying to think, can I reverse the order in such a way that we take advantage of this free, right? So then free, right? And then, so this is free, and then maybe another way to write it is just that new free is equal to s sub I plus 1, right? And then here we have new free, and this is print, and this is the thing here, right? So this is that's the tricky part that I kind of didn't really think about, because I didn't think it mattered, honestly. Or that was my thought process. I didn't think that it mattered. Is kind of rewriting it like this, right? Yeah. But it's just that in this case, this left is not the original left, right? Because as we also said before, you can kind of think of it as like start left or something like this. And then this is 0, for example. And, you know, start left. And then 3 is equal to s of start left. We kind of mentioned this very briefly, but I was doing the for loop the other way, as you saw where I did the new 3. I had new 3 on this side, and apparently is, you know, as a result, we didn't get to keep track of this start left thing, right? And here the start left is going to be s plus 1, and this is roughly the same thing, right? So if you kind of yeah, I mean, I think as a result, left is equal to right, so that's why, yeah. So this is an infinite loop just because s is equal to I, and we just kind of keep on going left is equal to left, and then just keeps on recursing. I mean, and that's kind of the reason why I changed it, so that that's why I had like the free stuff or the new free on the inside, because I knew that I was always incrementally making progress to get rid of that infinite loop. And as you kind of recall, we had to do something like if left is equal to right, then we return 1. So maybe this gets rid of the infinite loop. No, because actually, no, I don't know why it doesn't get rid of the infinite loop. Left is equal to left. Okay. And also technically this is wrong, right? As we said before, because I think you have to do something like if left is equal to start left, or like if s of left is equal to s start left, then we return 0. But okay, right? I mean, I think this is infinite looping for the same reason that we had before, right? So that's kind of, I don't remember what I'm doing anymore. Yeah, if you enjoyed this exploration, let me know. But what is the issue here? I mean, maybe, no, but this is before we start making the other optimization. Why is this infinite looping? Let me double check real quick. I mean, maybe it's just the 4, 5 thing again. 3, 4. I guess the same idea, really. Some of it is just recursion. Okay, so yeah, 3, 4, 0. 3, 4, 0. I mean, the reason, so 3, 4, 0, 1, 2, 3, 4, 0. Oh, no, this is right. But then we chopped it off. Oh, because this chopping it off maybe makes it an infinite loop. I actually don't know anymore. Yeah, I guess we just don't use free anyway. I mean, still maybe probably infinite loop. Oh, I still have to print. Oh, I do. Okay, now it goes to 4, 5, 4, right? And the reason is just the same thing that we had before, which is that we just have like 2 characters, and yeah, this is 1 character. This is left. Wait, 4, 5. Oh yeah. Because then now this is just a little bit awkward, which is, I guess we fixed it here. Because that, oh, what the? Because then now it's 2 characters. This loop's always going to make it 2 characters because we no longer trim, right? So yeah, so we just have to, I want to say we should remove this, but I don't know why. Oh, because before Okay, the reason is because I mean, I think this is fine though, right? Maybe we needed this part still. No, because it's not. Okay, well, that's a different one though. That's because you can just chop it off. Otherwise, we don't get it for free. So then now we want to paint min of I don't know. I'm kind of struggling here, but I think this is the idea that we were trying to do. And maybe if I mean, I know that I could resolve it by like using the same thing before, but that's like not really really productive, right? I'm trying to figure out how to kind of rederive this from first principles so that I can figure out how to learn from next time. The cost function is really yeah, because you can. Was basically the two, what I was saying about the second level of symmetry that we have to break is this idea of where to figure out the cost. And you could get the cost on two places, right? One is as you initially define it to print it. The second is at the very end, right? So, and here we did it at the very end, which is this part, and I guess maybe this part, because here, well, I mean, I guess this is actually awkward. I forget why this is because we can actually, if we have this loop, I don't think we need this, right? Because this is actually just part of this loop, right? So that's a little bit confusing maybe. Actually, let me check this case real quick as well. 56%. People just copy. It's no problem. So you have someone like this. So then here, I don't even think you need this. Right? Is that true? Or did I make that up? It's just that I needed this part. Is what I needed. The chopping. Oh. Does this not go to? Because the part that I removed, this should just be. Oh, I guess if you have two characters, this doesn't go to the right because we don't have a right plus one. Okay, fine. That's kind of hard. And in here, we're trying to. The awkward thing is that now left is not equal to start left, which is why this is going into a loop, right? Or like left, the character in left is not equal to start left, so then this never happens. And the plus one here also doesn't make sense anymore, right? Because yeah, I think ideally, well, we chop off the right, so we don't care about it. Okay, so and this is the new thing. But even as saying this is a new thing, that means that you need to, like, if we want to do the cost up front, I'm trying to figure out how that looks like. If this is a new thing, then we actually need to do a plus one on this thing and not this side, right? So it's a little bit awkward, or a lot awkward, to kind of do the conversion. I mean, the conversion is not hard. It's not hard if you know what you need to do to convert it, but I'm trying to rederive this from first principle of like getting from here to the other thing without, like, in a better way to, for it. I don't know that this is necessary, but maybe it's fine. But it goes in infinite mostly because we, yeah, so maybe we do something like this, and then maybe we replace it by so that we always make progress. Where do I have 3? Oh. Okay, so at least now it doesn't go into infinite loop, which is good, but we under count the cost of paint. Also, the comments no longer make sense. Might as well remove it. At least this one. So then now, because this is under counting the prints. Because this side also seems like it prints a new number, so because we do it there, so maybe we can do something like that, so then it goes over. Okay, that makes sense actually. Okay, still under though. That's odd. Well, I don't know. You need a +1 here, but that doesn't make sense either. I +1 left. Oh, maybe this is wrong because now that that would be new though. So yeah, I don't know. I'm trying to think still how to figure this out using this way with the start left that we said. We chop off. I mean, I want to keep this idea of chopping off in the beginning, which is why we have to start left. I'm just trying to get this right because, yeah, I'm just trying to understand this. This part is wrong. Well, maybe, I don't know. Because then now we never redefine start left. Though it's more correct apparently. Or maybe it's just this +1, but now that was wrong. Well, because the start left is a little bit awkward. Yeah, maybe I needed it here. But yeah. How is this wrong? Okay, let me step back for a second. No, not that one. This one. Oh wait, no, not this one. The time limited one. Okay, let's try again. So then we're 3, right? So now we just say start left. So then now we have new 3, which is fine, and then this is start left, right? No, this is new 3 is equal to this is the new left. New series in the middle. Yeah, because okay, yeah, because our original logic was that yeah, and then this is maybe 0 + 1. All right, I think this matches our original logic. I'm going to submit just to see if we get a. We should get a time limit exceeded because it doesn't really change anything. Maybe even memory limited, if whatever. But I just, yeah, at this point, I just want to make sure that we, TTD style, try to word it. And then the idea here that I wanted to do, as I was saying, is that the reason why it took me a while to debug it or to kind of come up with the other thing is because even though, as we said, this is going to be all possibilities, we wanted to keep, like we chopped off the left side to be used new. So here you can think about this as left side is new, new painting character or character to paint. where right side, same character, right? But we want to change this, so that's what I'm trying to figure out. So here, maybe I do start left on the left side, and then on the right side, so then now it would be I plus 1, right? Because now this is the same new character. It should give me the same answer, but it's giving me infinite loop instead. Why is that? Because this is, oh yeah, the same thing that we already said, which is that, so okay, so let's say left side, same character, right side, new character, right? So this part is probably fine because we just have a new character anyway. If nothing else, this part changes. But here, the start left is not, yeah, because it chops. Well, maybe if we do something like if s sub left is or s sub right is equal to s sub start left or 3, whatever. Then return paint min left right -1 start left. Would that have been good enough? No. I was hoping that this would resolve it, but what is my case that is infinity? Okay, so it is the left is equal to right case. I think we can add this thing, but then I think this just like shifts it to 3, 4, I think, right? Yeah. And the reason is because we have this chopping off thing, which is fine. But then now we need a, okay, I see. The reason is because we kept it so that the left side is at least 1 character, but it should be that the left side could be 0 characters. So then now it means that it's going to be just the right side. So that means that it's going to be I, well, actually, I guess just left, right, left plus 1, right? But then that shouldn't resolve the infinity character, right? It just means that we're changing it. And the 3, 4, 0, I mean, so actually, by the way of this chop, we know that that s of left and s of right is not equal to s of start left. So then maybe this doesn't make sense anyway. Okay, so then we know that this is the case. So that means that we need to print another color. So then on the left side, we want to keep the same colors, but we already chopped it off. And this allows us to print the new color. 340. Because of this thing. So then now, after we get rid of this thing. Oh, okay. So that's all I needed. Is that Maybe. I mean, this should still time limit exceeded. Which is, oh. Wait, did it just get accepted? Why is this better than 3? Huh. Am I dreaming? I thought I need to strip this out, but maybe Leetcode just has like weird test cases. I don't know. Okay, let's just say we have 3, right? Yeah, let's say we have 3. So this is equal to 3, this is equal to 3, whatever. Otherwise, this is not the same, so then now we chop it off, and then we just go say s sub left is the character, right? And then now, on the left side, it's going to be still the just 3. This is going to be the new character, so s sub I plus 1. Huh. Is it an input issue? I don't get it. I mean, we're basically doing the same thing, right? Maybe it's just Leetcode input is weak. I don't know. I mean, the other way is a tighter bound for sure. But I'm trying to think, why is this like the same thing? I mean, one possible reason, which I don't know yet, is that, you know, you could express 3 in terms of left in this particular way. But I don't know how, like, how do you, That's wild. I actually expected this to time out, because then now it makes it even more crazy, because, like, why would it matter that, you know, like, is it just an input thing? Like, basically we have this thing and this thing. What if I don't chop it off? Oh, then you just get the wrong answer, but okay, fine. But that's even... Why does chopping it off matter? But we don't chop off at the beginning. Does that work? Well, yeah, then you get infinite loop, but... I don't know. I think that's the thing, right? What you watch, I mean, I know that this, you know, we had the correct solution like, I don't know, 30 minutes ago. But this is what you're watching now is me trying to understand and learn from this problem. Hopefully for the last time, because I feel like apparently I didn't learn the last time. But I'm kind of confused. Let me look at my last year's solution real quick. I mean, basically it's the same. I don't know why this is faster. Is this faster? We could give it a quick submit just to see if it's still faster. And it is. But it should, but this solution should be the same as, well, not that one. This solution should this solution. Nope, I'm looking at one. But this solution should be the same as this one, though. Nope, not this one. But this one should be the same as my correct one. That's why I'm like a little bit confused as to why like this solution and this solution should be very similar. Oh, I even called it paint min last time too. Oh wait, no, I'm looking at the same day solution. Where's my old one? This one, right? Like, what's the difference other than using cache? Oh, this is just one, right? Again, though, why do you not just do... Yeah, I guess this doesn't take account of it. But why is my solution today so much slower? What is the difference? Is it the cache thing? I thought we did the cache thing here. Is it just because of this print? I mean, this is the only difference, is that I do the... Oh, I see. Because we iterate a lot more possibilities where I is not equal to the last. Okay, I see that. So is that the thing here? Is that... Okay, let me go back real quick. So this is the version. So using that analogy, maybe we use something like if. So then here, maybe we do I minus 1. If s sub I is equal to 3, then we can chop it off this way, right? Is that much faster? That's much faster, but... So then now we go back to my original time limited solution. Can that be fixed this way? This is what I mean by, like, when I solved it, right? I was like, is it a Leetcode thing, or is this... Alright, let me run it real quick to make sure that it is still the one that time limits. That's why I was wondering if this is a Leetcode thing or a Larry thing, right? And don't get me wrong, the other thing I think is much faster, just because it doesn't have to do with 3. Like it's all 26 faster. But, you know, so here if... So, okay. So because we want 3 on this side, we want if s of I is equal to 3, then we actually, because the plus one's on this side, if I is equal to 3, then we actually, this is going to be minus 1. And then it goes on the other side. So actually the loop looks exactly the same. So now I'm getting an infinity, because I guess this just never happens. Because of nothing else, so then now we have to paint one character at least. So to paint one character at least, we... Okay, so the first character is not the same, so then now this is going to be the new 3, right? So if s sub I is 3, we go to the right, and that's fine. But the new 3, so basically if none of the characters are the same, then best is equal to paint min of left, right, new 3 plus 1, right? I don't know, should not go in infinite loop, but is this fast enough? That is silly. Okay, well, I mean, this is like so input dependent, right? This is Leetcode input dependent thing, so I don't know what to say. And I had this, what is this, 127? I had this an hour and 10 minutes ago, which means I still took like about 40 minutes, but at least like it's a reasonable 40 minutes. I didn't think that this minor change would make that much difference, but Leetcode inputs are that way. I mean, it's not just that. Partly is Leetcode input perhaps, but this actually makes it so that the number of states are a lot less. I think that's the major critical point, right? Because before this, without this if statement, and you still don't need it per se, you could actually, this would work without it. This goes to I instead. The thing is that this thing has a lot more states. Yeah, this thing has a lot more states because s sub I plus 1 is not equal to 3, so then you have to do another loop of this anyway. So then this 3 thing gets past all the entire n square, where if you have this loop, or if you have this if statement, maybe it becomes n square. Because now, okay, that is tough. Because basically, another way to think about it, if we didn't have this statement, what ends up happening is that this 3 gets passed through all substrings, all possible sub things. So then now this becomes n squared times 3, like a hard n squared times 3. But then now here, if s sub I is equal to 3, then at the very least, well, that means that here and here not here, but in a way that it would create a new one anyway. So all these states gets rolled up together. But that means that do I even need this? I want to. I think we don't need this. Okay, we need it for loop termination. Oh yeah, because otherwise this would be infinity. Well, I mean, because the reason is that the invariant here now then, okay, I see it. Maybe this is another way of phrasing it, right? So then, let me try again. If we didn't have this if statement, the thing is that, okay, so the new 3 part, this part has an assumption that new 3 is the same as the left, right? But this part, because we pass along 3, even if it didn't match the previous one, then this 3 will not necessarily equal to I plus 1. And also, this doesn't happen. So then what happens is that this character now pass on multiple recursion loops of here, right? If that makes sense. I mean, I'm seeing it, but I don't know if I'm explaining it right. Wow, this if, I mean, it makes sense now. I could see why. It's not that it is Leetcode. I mean, some part of it, kind of, I guess, but But with this if statement, then now s of left is equal to 3 with every new core. Yeah, s of 3 is every new core. And what I mean by that is that the only time s sub left is not equal to 3 is if we need to pass if s sub left is the first character in the string where this is the case, right? In the substring, kind of. So this is with the if statement. Without the if statement, 3 gets passed down everywhere. I think that's basically the idea, right? So we were kind of right, but I guess I was sloppy without the if statement to kind of think about, and this is why you have to, keep on studying, because sometimes very subtle things, you just don't take it I took it for granted that it doesn't matter. And technically it doesn't matter because it is brute force in that way. But for example, what I mean by that is that, for example, let's say you have, I don't know, A, B, C, D, E, F, G, right? Something like that. In this case, even in the case where we just ignore the left side, right? Then now, just the right side, right? We get without the if statement. Then just the right side of, I don't know why. No, I mean, it's fine. Just the right side. We do paint. Okay. We do I plus 1, right? A, right? So whatever it is. So this is, so starting from 0 it goes 1. The right is going to be n minus 1, so like whatever, 7 or 8, right? So 1, 8, and this also calls, but this goes for all the things, and then now it does this part again. So then now it tries to do paint min of 2, 8, A, and this calls paint min 3, 8, A, dot, right? So that's the issue, is that that's what I mean by it gets passed around, is that this A gets passed around from all the substrings, even though you see that there's no reason for it, because there's no more A's in the future. So then now this makes it a hard n squared times 26, or alpha, if you want to call it that, alpha, which is correct, but with the if statement, it is the first character in the string where this is the case, meaning that this means that for every left index, it is either equal to 3, which we already said, honestly, or one other character, right? Because if it's equal to 3, then, we just, there are a number of ways we do this to make sure that's equal to 3, right? But if it is not equal to 3, it can only be one character. Is that true? Maybe it's not quite true, actually. Oh, no, this part is a new 3. So that means that left is equal to new 3 by definition. This part is it's only so. Or another way to phrase it is that, oh yeah, it is one other character. It is going to be equal to left s of left minus 1. Oh, sorry, that's not true. It's equal to 3, right? Yeah, because then now this part can only be true if s sub I is equal to 3. So that means that, and because left s sub left minus 1 can only be one character, that means that there are only 2 cases. So then now, as a result, this becomes O of n squared times 2, which is obviously O of n squared. Wow. Wow. And that is the subtlety of an if statement. Wow. And of course you could do it the crazy way, which I eventually did with the reversing symmetry part. With I think this one. Right? Is it this one? Which is also ridiculously hard to come up with, but I mean, I don't know. At least for me, I feel like this way that I did it was intuitive up until I got it wrong. But maybe I could have gotten like, and as you can see though, now that we have a better understanding of this, you can see that it doesn't matter where this is new 3, like it doesn't matter. The idea of it is less interesting in the sense that, oh sorry, I don't even mean it that. I meant like the specific ordering doesn't matter, right? Because we did it both ways. We did it one way with the left side is equal to 3, or we cut it up such that we draw the right side with the character we get for 3 and keep going, or we keep going with the right side, or we also drew it such that we kept going with the left side, right? We have both solutions here, so yeah. So we have this part and also this part, right? So we have 3 on the left side and 3 on the right side, and it still works. So it doesn't even matter. Because I think that's probably one of the thing, right? Is that I was trying to figure out why it matters. Like I know that I talked a lot about symmetry, but for me, intuitively, it shouldn't matter how you break down the part and which part corresponds to which part. But wow, just this if statement. This if statement is ridiculous. Wow. Okay, I mean, yeah. We often talk about, I think one thing is that we talk about how we can express things in terms of another. And here, we basically, even though this 3 has a range of 0 to 26 or whatever, 0 to 25, maybe with an empty string if you want to count that. But it basically, what happens is that now, if you really go through all the things, and you know, there's a symmetry, it doesn't matter whether it's the left or the right, you have a similar idea, but because of this if statement, this implies that here, the 3 is equal to the previous thing, right? It becomes a Boolean flag whether, yeah, you know, where left sub I is equal to 3, so man. Can we get rid of this now? I think maybe. I don't remember. Okay. I don't know why we need it though. Maybe we still need it. Because this is the new. I mean, in theory, just chop it off, right? Oh, I guess because of this part. Yeah, so I think we can do something like. No, I mean, I guess this is the most precise way of putting it. Because I was gonna write something like if 3 is not equal to, but I guess it ends up being this, and you may just like you don't have because this is just like writing it in a way such that you chop off the first and then you chop off the new 3 on the first, but then like if you could remove this if you have something like if left is equal to right, return 1. If s of left is equal to 3, return 0. I think this works in getting rid of the infinite loop. Maybe I could be wrong. Okay, maybe I'm wrong. Maybe there's some like small cases here. Oh, this. I think it's just because this part now, I mean, like now we got rid of this part, but this part new infinite loops because it just keeps going calling itself to the same parameter if left is equal to thing, right? So maybe you can rewrite as s is equal to infinity, and then if new 3 is not equal to 3, then we do this, and then I think that works. Okay, I'm lying again. This is one character, so that should return, but yeah, I guess there's always infinite loops because if I is equal to right, then this is the same input. Yeah. So, oh wait, no, but I cannot be equal to right if any. No, I guess the last character. So if the last character is equal to 3, then wait, why is this I and not I minus 1? Was this I minus 1? Did I mess this up? This is I minus 1, right? Was I messing up with things? Yeah, okay. Okay, so, why? Maybe I was mucking with doing it, but okay, so then now we should be able to do this, right? Because now the I no longer goes to infinity. Oh yeah, this part still does, so then we do maybe mess it, right? And then if new 3 is not equal to 3, okay, I mean at least it does an infinite loop. It does not infinite loop. Oh, because I didn't do the thing where left is equal to right. We need to do something like this. We return 1 unless if s of left is equal to 3, then we're going to return 0 because we chop it off. Huh. I guess we do need it. It has to do with awkward though, but what is the case that I'm missing that is giving this? The new 3. I guess we have to handle the case where we have to handle the case where this is the first character, which is of course what we do here. So I mean I think we don't need it to return, which makes it a little bit confusing, but we need something like this where like you could imagine yourself doing this because even though we just return it, so it's fine. But I think this is a little bit more general. And the reason is because, and it's a little bit slower for that reason, because you can think about this as like, this is the part where, so there are two cases that is not encapsulated in this for loop, which is that if the left side is empty, right, and then, which I guess does get encapsulated. But the thing is that it gets encapsulated incorrectly, because if this is empty, then this one part is no longer true, right? So maybe we just do another if statement within it, but then it ends up being this thing. So that's where I have to take account for it. And then this part, we just have to take account the part that this part is empty, which maybe is fine. Maybe we don't need this, actually, because, oh no, we need this to take account the part that this if statement never happens. So then now this is just an entire string. So, and I know that this is an else, they're complementary, but I'm just, learning how to get around with it. But yeah, all right. It's a very long video, very long problem. I think the way that I mean, I'm just gonna, we don't need all this stuff. I think the way that this is probably the canonical way that I like to kind of go over it. It's a little bit cleaner, but yeah. That's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.